Hello, everyone. I'm Matej, and I'm a machine learning engineer in Microblink. And today I'm going to talk about our solution for the in-store product recognition system using deep learning and various other AI techniques. So let's start. To start, let's clarify our vision as an AI company. And that vision is bringing the benefits of AI to every person on Earth, to each and every one of us. We believe in the power of AI to dramatically reshape our lives for the better. If we can draw a line between our product and the end user product, and the end user in general, then we won't build that product. That's kind of our goal. So we currently implement our vision to our two main business units, and we call them commerce and identity. So let me briefly introduce those two businesses. In the identity business, we explore the world of identity documents, ranging from personal ID cards and passports all the way through credit and debit cards, etc. We have a strong experience with document scanning using computer vision powered with AI. And today we offer solutions for document and identity verification, document identity fraud detection, real-time solutions for digital customer onboarding, etc., etc. On the other hand, in our commerce business, we traditionally dealt with scanning receipts. And we expanded our business to e-commerce recently, narrowing the gap between conveniences and services you have in stores and online shopping, etc. To minimize this gap even further, that's actually the topic of this presentation today, I will show you a new and cool product that will add on to this commerce suite of our products, of our existing products. First to run through some numbers. So on the identity business side, we scan more than 700 million documents each year. We support more than 2,000 different document types across 138 countries. On the commerce side, though, we process more than 3 billion transactions in the US alone, which is around 10% of all transactions in the United States per year. And also we support more than 600,000 unique products in our product catalog, with plans to expand that product catalog to up to 5 million products really soon. So our general impact on the market, we estimate that our technology reaches more than 500 million end users through more than 1,000 applications of our clients. And those applications are spread across 20 industries in more than 80 countries. So I'd say those are pretty impressive numbers. Now, let's talk about AI at Microblink, which is probably why we are here. Back in 2015, we saw the potential of building a strong AI team and a strong AI infrastructure. Today, our AI department is 50 engineers strong. 15 of those 50 engineers are actually the ML engineers, and the rest is for supporting building the ML infrastructure. We also have a very strong data annotation team with more than 150 data annotators. Our AI platform powers our two business units, the commerce and the identity, by covering the complete AI development process and delivering production-ready models for the two business units. We see the potential in powering outside clients with our AI technologies as well, and have plans to expand our AI department as a separate business unit. And on the AI, for the AI numbers, as I said, we have 15 and more people strong ML team. We invested more than 45,000 hours in data annotation in this year alone, which roughly sums up to about 8 million annotations in this year so far. And we, on average, run 1,500 machine learning experiments per month. So we're quite busy. We also deploy more than 50 production-ready models. 85% of those models is capable of running on edge devices, on mobile devices, which is kind of our strong point. And we also, on average, have a 40% faster models than industry state-of-the-art in regards to inference speed, and that is because of our custom inference engine that we built over the years. Well, enough about Microblink as a company. Let's dive into the problem setting for today. So in recent years, online shopping has seen a staggering growth in rising popularity. offering convenient shopping from your home, as well as additional and cool conveniences and customer benefits displayed here. We're talking about ratings and reviews of products, recommendations, dietary information, real-time promotions, price ranges and maybe other products and other sites, etc. On the other hand, shopping in-store didn't fall behind, as some of you might think. However, traditional in-store shopping offers customers and businesses only a fraction of the services that online shopping offers, mostly covered with coupons and vouchers and combining the loyalty programs, with no any real-time action or real-time information. And the information we don't have but would like to have is information about out-of-stock items, real-time promotions for customers, real-time info about prices and other sites, and all those ratings and recommendations, etc. So we don't have any way to have that now. Well, let's see how in Microblink we decided to minimize this gap between online and in-store shopping by introducing product recognition into our existing commerce product. So I will just play a quick video right now. Hope you enjoy it.
Let's explore the ways Microblink helps you reinvent the customer shopping experience. Microblink Discovery puts your customers' favorite products right into their hands. We're talking ratings, reviews, dietary information, real-time promotions, all at a glance, while they shop. So you can give them that comprehensive online shopping experience they love, directly in their favorite store. Reimagine your rewards program with Microblink Loyalty. After purchases, customers can scan their receipt to gain instant access to loyalty points, personalized promotions, maybe a surprise deal for their next visit. Talk about rewarding. Microblink's product intelligence is constantly improving, processing over 3 billion transactions each year. So you get access to valuable purchase insights in real time, and can pass that value on to your customers just as quickly. Together, we are making an everyday shopping experience magical.
Okay, I hope you get the idea of this video, and I hope you find it inspiring. So, in order to implement this in-store discovery solution that will help us with all these benefits that I listed before, we needed to design and build our product recognition pipeline. So we had to solve a broad spectrum of classic computer vision problems, such as classification, object detection, semantic segmentation, representation learning, etc., etc. So let's dive into some technicalities right now. Here you can see our product recognition AI pipeline in this general view. It's a composite system consisting of several deep learning models with a final heuristic-based re-ranking component at the end. The idea is to detect and recognize all the products on a captured image in store in order to retrieve their information and metadata from the database, offering valuable product insights to customers, clients, and pretty much everyone. The pipeline consists of 3 parallel tracks. We are talking about the product track, a price tag track, and a shelf track. I will go into those in more detail in a minute. All the models in this pipeline are built using our custom optimized layers and components and wrappers. And note that for pretty much all models in the pipeline, we eventually annotated our own data in order to eliminate the domain gap problems that come with training on publicly available datasets, since this is a kind of specific problem we have to solve here. Okay, so to start with our pipeline, at the beginning of the pipeline, we capture images in real time, periodically. We send the image to the blur classification component in order to detect any kind of motion blurriness or to determine if the image is okay. And if it is, we can send it further into the pipeline to the parallel tracks. The first track I'm going to talk about is a product track. And the first model here, the first component, is the product detector. The product detector has a task of detecting as many products on the image as possible. Dealing with the task of object detection, the model needs to be fast, yet accurate in order to discard irrelevant objects in the image. Our long-time proficiency in object detection gave us the know-how to reach up to 95% F1 metrics for this problem of detection here. While our custom object detection framework and our inference engine gave us the speeds and reduced the inference time up to 50 milliseconds, which is pretty impressive. And I'm not talking about those newest devices. I'm talking about just regular phones. Initially starting with open source SKU data for this training, getting our own annotation over time drastically increased accuracy of this model and performance. We also experimented with kind of different architectures and feature extractors and so on. Next logical step in the pipeline would be to classify all the products that the detector detected. But we have a problem here. Since there are thousands and thousands of unique products, standard classification tests would result in class explosion. We decided to solve this problem as an embedding retrieval problem, calculating the embedding vector for every product that we capture. With this setup, adding additional new products doesn't require model retrain. You just need to run the new product image through your model to calculate the vector, put it in a database, and index it. And you can use it for search later. Determining the optimal learning process, loss, optimization, architecture, and hyperparameters was a tricky one for this model, as well as complex data acquisition and data annotation. The embedding vector is sent to the retrieval component, which is on backend, which uses the vector search engine that tries to produce product candidates from vectors of the products we have indexed in our database. So you can pick a number of, I don't know, K-top candidates that you want to pick from the index base. With this approach, we only need to send numerical data to the backend, skipping any image sending that requires a good network bandwidth and speed, avoiding large image transfers. We managed to achieve up to 90% precision at one for this task, which is also pretty impressive. Additionally, on the product crops level, we try to extract the text from product packages in the product package OCR component. The extracted text is then sent to the final re-ranking in order to boost re-ranking performance of the candidates we listed on the previous slide. Since we are dealing with arbitrary shaped text on product packages, this model is also a tricky one, and we are still developing our internal solution. While open source solutions for this problem are known and are available online, and we are currently testing them, we are talking about very large and very slow architectures not suited for our use case of running all those models on edge devices and mobile phones. The next track here is the price tag track, and the first component that comes here is price tag detector. So on this level, we try to detect all the price tags we can find on shelves. We also can detect some promotions or some information tags that you usually also find below the products. And we also try to match and correspond every price tag to the product. We can perform also a kind of a de-warping if we have some angle perspectives when we are capturing images, and so to boost the OCR performance of price tag that comes next in the pipeline. So all the detected price tags are then individually set to the price tag OCR component to extract the relevant price information, promotions, infos, etc. The very tricky issue here is, of course, image resolution, since price tags are relatively small compared to products on your image. However, we managed to achieve great performance for reading prices with up to 95% mean detection of classification F1 metrics. The OCR accuracy and overall recall of detected characters and numbers improves even more when closing up toward the shelf, increasing the price tag resolution, which is logical. On our final parallel track, the shelf level, we segment the image pixel regions into corresponding segmentation masks that correspond to shelves. Why do we do that? Well, those shelf segmentation masks are then used to approximate shelf lines. We can also use those lines to pick good reference point and perform kind of an image input de-warping if we also have some angle perspectives when users capture our images. And de-warping of capture images usually boosts the performance of the entire pipeline. We also use those shelf information for product placing on shelves in order to determine which product is on which shelf, which is very valuable information for businesses that pay a lot of money in contracts to the retailers, so their products are exactly on the shelf they were meant to be. We can also do empty shelf detection to analyze if we have some out-of-stock items, etc. On the end of the pipeline, finally, we performed the final heuristic-based re-ranking of the top care results of our retrieval we done earlier, utilizing all the relevant product information that we extracted from the image processing models throughout the whole pipeline. The final result, refinement, produces the target product for every product crop that we're detecting on the image, offering all the specific and valuable product information stored in our product database. And that can be prices, that can be prices in other stores, dietary information, or pretty much everything that you can store in a database related to that product. So if the pipeline itself is not impressive enough, think about the fact that all the image processing models in the pipeline are capable of running on mobile devices via a custom inference engine. You can see actually the demo here. On our mobile app demo, our developers implemented a smooth user experience utilizing hardware acceleration if possible, if available. Remember that the product recognition pipeline is tested on a broad spectrum of mobile devices, offering smooth performance even on lower-end devices, not just the best devices we have. So you can check out the demo in the hallway on our booth, and yeah, I hope you like it, actually. So this is a rather short presentation compared to others, but to conclude, we have an intelligent and convenient solution to a day-to-day shopping problem, and we introduce cutting-edge, fast, and mobile device-compliant AI pipeline. Completing our Microblink commerce stack and commerce suite, we've come a long way of removing boundaries between brands, customers for both in-store and online scenarios. So I hope that you can see the potential to revolutionize our in-store shopping experience. And if you want to talk about any components of the pipeline or whatever in more detail, you can come check us out later in our booth. So that would actually be all from me. Hope you enjoyed this presentation, and I will answer any questions gladly if you have some. Thank you.